Okay, good afternoon. Good afternoon, everyone. So we start now lah. Okay. If you are not talking, you switch off your microphone lah. Unless you want to ask any question, then you on your microphone lah. Can or not? Oh, these are Yun Xiaohui problems. Yun Si problem. Use handphone computer cannot come in now. Okay. You still have your lesson 1. Lesson 1 with you or not? Okay, we discussed most of the question already in our last lesson. You remember or not? In our last lesson, we learned this right-hand grip rule, right? We also learned this the uses of electromagnetic, right? The uses of electromagnetic, such as electrical bell. You learn the bell, how the bell use a concept, right? After that, we also learned this electromagnetic relay switch, right? Relay switch. And also you learn this circuit breaker, right? Circuit breaker, remember or not? Circuit breaker. And the last one you learned in your last lesson was this telephone earpiece, our telephone earpiece, how to use a concept of electromagnetic. Now only come. Okay. All right, let's start our lesson now. Okay. Hi, Chu Kaiji. Now you are the only one show your face here. Kaiji, how are you? Huh? How are you?
Yes, very good.
Very good, huh? Okay. Come, let's start now, huh? Okay. We are in the last question now. Okay, this question. Okay, can you see? Look at this question, huh? This one is an essay question, experiment report. Okay, this question, huh? Now you need to have foolscap paper in your class. You must have foolscap paper to write out the answer. Okay. This question sound like this, Figure shows an electromagnetic lifting machine. Okay, lifting machine means is a machine used to carry metal. Okay, you see this machine when you on electric, you look at the pictures here. You on the machine, this piece of thing will become magnet. So it will be used to attract the metal, to carry the metal, right? This piece of thing called lifting machine. Okay. This one was a SPM question, okay? Machine used to lift scrap metal. Show the observation of machine when current flow through the machine increase. Now you see the second diagram. First diagram, less metal attracted. Less, you see here, less. Because the current small. When the current small, less metal attracted. Second diagram show that the same machine, you increase the current. Now more current, right? You can see that this machine attract more metal. Okay, more metal being attracted there already. Understand? So it's very clear now. This diagram show the relationship between what? Is between, I see when the current bigger, you see when the current is bigger, right? Stronger magnetic field strength. Okay, bigger current it show stronger magnetic field strength. Okay, so in other words means this experiment is a relationship between electric current, between the current and the strength of magnetic field. Okay, we already know the answer one is directly proportional, right? Meaning that you have bigger current, more current, right? Then you can produce a stronger magnetic field strength, correct or not? That is a concept. Okay, now we're going to answer the question. Okay, the first one, as usual, let me take out the pen first. Because time to time still got people come in here. Okay, so first question you are supposed to write inference. Okay, to write inference. So how to write the inference here? Based on a diagram. Okay, the inference, the answer is like this. You can see the answer. Okay. The strength of magnetic field depends on the current. We use the word depends. Understand the keyword depends. The strength of the magnetic field depends on the current. Okay. The strength of magnetic field depends on the current. So we use the word keyword depends here now for writing this inference. Understand? So this one okay, done. Okay, the second one is hypothesis. Okay, hypothesis. Hypothesis is right. Okay, hypothesis, I don't have answer here. Can someone tell me what is hypothesis here? How to write hypothesis for this question? Harry Young, are you there? Harry,
Yes.
can you tell me how to write the hypothesis for this experiment?
Higher
what?
The higher the current.
Yes, the higher the current,
the stronger the strength of magnetic field.
Yes, very good answer. The higher the current, the stronger the strength of magnetic field. That one is the hypothesis. Okay. C. Question C. You have to be careful already. C. They ask you to use this one or use a connection wires. Use a switch. Use a soft iron core. Soft iron core. Just a piece of soft iron. Solenoid. Solenoid means it's a coil of wire, one coil of wire, solenoid. And other apparatus describe the experiment framework. Okay. Okay. The rest are variable. All these are okay. All these actually is in the experiment we already discussed. Okay. Let's go to the answer. Okay. You refer to page 3. You can look at your paper, page 3. Okay. Page 3. The experiment is there. I just want to tell you something now. What to write, you can write later. Page 3 is here. It's here now. Okay. Hypothesis is here now. M. Okay. M, please write this. To investigate the relationship between the strength of current and the strength of electromagnetic and the current. Okay. So this is a M. Investigate the relationship between the strength of electromagnetic and the current. Okay. The next one is variable. This one you can copy. Manipulated current is correct. We manipulate the current. We control the current. Okay. Responding variable. Please cancel this one. This one wrong. Don't use this one. Responding variable, cancel this one. Okay. Please write this. The number of iron nails attracted. This is a responding variable. This is something we are going to measure in the experiment. Please write this answer. The number of iron nails attracted by the magnet. We are going to count how many iron nails can be attracted by the electromagnet produced. Okay. And fixed variable, constant variable, very important. You must have these two. You got people coming on. Okay. Constant variable is the number of turns of solenoid. This one cannot be changed. The number of turns must stay constant. And the next one is the types of core. We use soft iron. Cannot change. So remember, constant variable number of turns of solenoid and the types of core. Okay, the types of core given in the question is soft iron. So we cannot change. Okay. Right. List of apparatus this one you can copy. We use ammeter, connection wire, a rheostat. Rheostat is important because we need use rheostat to control the current. A retort stand, a switch, DC power supply. We use DC power supply. No, you cannot just write power supply. You must write DC or AC. So here is DC. And also you use a soft iron core, solenoid, and small iron nail, and also plastic container. All these. Okay. This one you can copy later lah. Okay, now the diagram is like, look at the diagram of the experiment. The diagram. Okay. Diagram you can draw later on. Follow the paper you have. This one is a retort stand. This is a solenoid. Inside the solenoid is a soft iron core. Okay, soft iron core is inside. Then the wire is widening outside. So this is the dry cell. This is power supply. This is a rheostat. Rheostat is very important. This is a switch. This is an ammeter to record the current. Okay, and the iron nail put here, put inside the plastic container, the iron nail. Okay, so procedure. Now next one is procedure. You change a little bit. And don't copy everything, you know. Okay, first you say the switch is closed. You on the switch here. Okay. Second, the reading of ammeter is set to 0.2 ampere. We start adjust the rheostat. Set the current start with 0.2 ampere. Understand? Start with small current 0.2. So you must write it, you know. The reading of ammeter is set to 0.2 ampere. Not enough. You must write by adjusting the rheostat. The latest marking scheme you have to write how. So I said it again. You should write the reading of the ammeter is set to 0.2 ampere by adjusting the rheostat. You must say adjusting the rheostat. Adjust the rheostat to adjust the current 0.2. Understand? Okay, now next. The end of the solenoid dip into the plastic. And now this step you can just follow. Actually, no need put this one down. We can carry this container go up. Okay. Place this container, go up for a few seconds to allow this electromagnet to attract the iron nail. Because when you let current flow through here become electromagnet. So when you put this one nearby here, it will attract the iron nail. Correct or not? Okay. The end of solenoid dip into the, you can put this one down, but every time you want to put it down, typically you need to open up the retort stand, the clip. Right? I think you better lift this thing up. Lift this thing up for a few seconds here. Okay. All right, then next is the plastic container is removed and the number of nails attracted to the electromagnet is counted. And this one must write counted. How many iron nails attracted to the electromagnet is counted. Okay. Then last is the repetition. The experiment repeated 5 times. You repeat a few times with different values of current. You cannot say like this in your exam answer, you know. You must write the experiment repeated 5 times with different values of current by adjusting the rheostat. Okay, you must state the current you use. Just now was 0.2. Now you must state 0.4, 0.6, 0.8, 1.0, and 1.2. You increase the current. Understand? That will be your procedure. Okay. Later on, you check the answer, you copy. Please learn how to write the answer. Don't assume you know. No, you have to practice to write it out. Okay. Okay. After procedure is tabulation of data. Okay. A table. Okay. A table. Don't use a horizontal table. Use vertical. Vertical means the table like this. Okay. Can you do it? Please follow do the table like that. 2 columns okay, like that, vertical. Okay, 2 columns here put current, here put number of iron nail attracted. Okay, put it vertical the table. Okay. Okay, and then last will be the way you analyze, right? So analyze here, you plot the graph. So the graph you plot, you just mention plot the graph of n number of nails attracted against the current. Okay, then you show the graph. When you show the graph, here is n number of iron nail attracted. Here is current. This line you need to show. In your answer, don't need. You just label y-axis is what, x-axis is what. Finish already. Okay. So this line I remind you, don't need to draw one. No need to draw in your answer. If you draw correctly, it's okay or not. If you draw wrongly, that minus mark. Okay. So it's better, safer. You just put X is what, Y is what. This line don't draw. Understand? Yeah. So this is one of the SPM question, okay? So I hope you all know at least you take a piece of paper, put some effort, go and write it down, okay? Write it down as a practice for yourself. Don't assume you have the paper, then you know. Okay, no. The answer is in your paper, I know. It's in the paper, then it's still in the paper, no, not inside your brain. Then to make the answer come into your brain, you must practice. Understand? Use a piece of paper, write it down. Understand? Okay, Okay, so this we finished up lesson 1 already. Okay, we finished up lesson 1 now. Okay, you can take all the answer later on follow the YouTube or whatever Okay. Yeah. So lesson 1 finished. We're going to start lesson 2. Okay. Lesson 2 is very technical. Okay. Technical. So far, you all can understand or not? So far, okay or not all? Belton now Belton still hanging there. Now come in. All right. Jeff, this one now only coming. Okay, come. Let's carry on now. Right. Okay. Now you should have this paper now. Okay. You have this paper with you, lesson 2. Okay, lesson 2 paper now. All right. This lesson 2, you see the title. The title is Understanding Force on the Current Carrying Conductor in the Magnetic Field. What is the meaning of that? Why the title so long one? Okay, let me explain to you first. Okay, this lesson 2 means you're going to study. First is the force on the current carrying conductor means a wire carry current. This one is number 2. So second one, first thing is a force. Second is a current inside a conductor, inside a wire. And the last part will be magnetic field. So meaning that 3 things here, force, current, and magnetic field. Okay, actually what relationship between them is like this, Okay, very simple. You just listen to what I say now. When current flow in a wire inside a magnetic field, a force will be produced. Okay, I say that again, you listen now. When current flow through a conductor, inside a magnetic field, then a force will be produced. Do you get it or not? Do you get it? Yuan Ân, are you still there now? Tan Yuan Ân still there or not? No more there. Okay, please get the meaning. Okay. When current flow in a wire inside a magnetic field, a force is produced. Understand? Okay, come. Let's look at the paper now. I'm going to explain very, very slow. Okay, come. Okay, first is this one. Look at this diagram. This diagram. You all have to pay attention, Pay class. You all must learn how to focus by looking at the screen already, You cannot expect, like in the classroom, your teacher facing you, teach you, no, cannot already. I think the earlier you can go back to school is after Hari Raya only, That only we predict after Hari Raya, they will allow you to go back. The earliest is after Hari Raya, okay? So meaning that you see a long time, you need to learn, you need to study using your handphone, using your computer, okay, online. I have to learn like that, okay? Right, in this diagram you see now, okay, this is a power supply now. This is a magnet, okay, you see this one is magnet, this is north, up here another piece of magnet. This one is iron yoke, a piece of iron, okay? So we call it C-shaped iron yoke. It's C-shaped, you know, because it's like a C, right? Not? So this is a piece of iron. So you put the magnet, one put at the bottom, the other one put at the top. So let's say this one is north, this one is south. Magnet must have north pole, south pole one, isn't it? So let's say this one is north, this is south, right? Okay, then you have two pieces of long wire. One wire here, very long one, hanging here. Another piece of wire hanging here. Okay, and these two pieces of wire, they don't connect one, you know. We use another short copper wire here. You see another short copper wire. Short copper wire. This piece of short copper wire, you hang it there to conduct the current. Okay, you see what happens is like this, you know. When we allow the current to flow, right? So the current come out from positive, then it cross over, follow this wire, it cross over, and then it come back. I said it again, the current come out from the positive terminal, follow this short wire, cross over, because it's touching right here, touching, so you can conduct, cross over, and then go back. Okay, now what happened now? Immediately you notice when the current flow like this, right? You can notice this short wire being pushed to the left side. You can see this short wire move to the left. You move to the left side, you know. Move to the left side means there is a force. The force push the wire, move to the left side. Okay, it's proven here, you see now. Listen, you know, okay, please pay attention, everyone. Okay, when current flow through, here got magnetic field, north, south, here got magnetic field, isn't it? North, south, so here got magnetic field. Magnetic field direction is from north to south, okay? Here got magnetic field. So you have current, as I say, current flow through magnetic field, okay? When current flow through a magnetic field, right, there will be a force. So this force is produced and push the wire to the left side. Understand? This concept is very important, okay? So when you have current, the current must flow. We don't see the current here, don't see the current here, only see the current here, inside the magnetic field one. Because magnetic field is here, north to south. So when current flow through magnetic field, it produces a force. And then the force sometimes push to the left, sometimes push to the right. There's another method to determine one, you know. Okay? Yeah. And now we go through the paper here. When the power supply is switched on, the short copper wire move to the left, okay? Later on, I tell you why move to the left, okay? And then follow here. When the switch is on, the current flow through the short copper wire, okay? The current flow through this short copper wire, okay? Produce a magnetic field. Last lesson 1, you learned, right? When current flow through any wire, it can produce a magnetic field, correct or not? So meaning that when current goes through this wire, it produces a magnetic field. Still remember or not, can use your left hand, right hand grip rule to determine the direction of magnet, isn't it? Okay. Short copper wire produce magnetic field. Then, one more thing here. I say very technical. You see here. In this place, there are two magnetic fields, you know. One is a magnetic field because of the current flowing here. Surrounding the wire got one magnetic field. Another magnetic field is from this permanent magnet, north to south. So got two magnetic field here. One is from the permanent magnet, one is from the current. So these two magnetic fields are the clash. So you see what happened here. We don't use the word clash, we say interaction. The interaction between the magnetic field produced by the current and the magnetic field of the permanent magnet, okay, occur. The interaction between magnetic field produced by the current and the magnetic field by the permanent magnet occur, right? Then the interaction between the two magnetic field produces a force on the conductor. This is a whole concept. If people ask you why there is a force, ini tunggu aturaman masuk. Nama dia tunggu aturaman. Okay, Fasli nama dia. Alright, so the whole concept is like this. When you allow current to flow through a magnetic field, current flow through a magnetic field, right? So interaction between the two magnetic field, the magnetic field by the current and the magnetic field by the permanent magnet interact. So the interaction produce a force. Okay, so produce a force. Okay, now method to determine the direction of force is Fleming's left-hand rule. Please highlight Fleming's left-hand rule. You learn a lot of hand one. No? In lesson one, you don't right-hand grip rule. This one right-hand grip rule or something like this, right? Now another one, Fleming's left-hand rules. Okay, Fleming's left-hand rule. You look at the pictures. Is here. No? Use your left hand. Why? Got name one, Fleming's left-hand rule. Why Fleming? Because Fleming's identify this method, use his hand to tell the world. So we use his name to remember him. Fleming's left-hand rule. Okay, look at here now. Your three fingers must be like this. Wait, follow here, please. Your thumb, your left hand, not your right hand, left hand. Thumb and your first finger here must be 90 degrees. You see or not? 90 degrees. Okay, and your first finger and your second finger, this is first finger, this is your second finger, also must be 90 degrees. So all the three fingers must be 90 degrees to each other one. Okay, you see this diagram. Your thumb and your first finger here must be 90 degrees. Okay, remember it's 90 degrees here. 90 degrees. And your first fingers and your second finger here also must be 90. So remember, here is 90 degrees. Here also 90 degrees. Okay? Can you show me your hand? Show me your left hand. Fleming's left hand rule. Okay, come, let me see your fingers. Yes, correct. Left hand rule. Okay? Right. Now you remember it. Your thumb. Thumb is pointing the direction of force. Please jot down. Thumb is pointing to the direction of the force, and your first fingers is direction of the magnetic field. Magnetic field, magnetic field means from north to south. So remember that. See, this fingers is pointing the magnetic field. Follow north to south. Okay, and the second fingers is follow the direction of current. So there are three things. This one is magnetic field, north to south. The first finger. This second finger is direction of the current. And finally, your thumb is the direction of the force. So how to use this hand on the first diagram? Now you remember, thumb is force, first finger is magnetic field. Third one, second finger is current. And now you see the diagram. On this diagram, why my hand is like that? You see carefully why my left hand, Fleming left hand rule is like that. Why first finger point up? Okay, first I want to tell you, you use your first fingers to follow the magnet. You see, magnet north, south, go up. North here, south here, so you point up. So this finger point up. You can use your hand to follow now. Left hand, Fleming's left hand. Okay, so this finger point up. Why point up? Because north to south. Okay, north to south. This is north, this is south. So you point up here. Then, okay, another thing I want to tell you, when you are using your Fleming's left hand, once you are using already, all your three fingers must be locked. Lock means cannot be moved, don't move anymore, cannot move already. Once you want to use it, so you have to lock it. 1, 2, 3, lock it like that. You can only turn your arm like that without moving your fingers, understand? Your finger cannot move one. The three finger must be locked, no, 90 degrees to each other. You can only turn your arm upside down only, but your 3 fingers must be locked up. Understand or not? Lock up your 3 fingers. Don't keep on moving your finger. That one is wrong. You cannot. Once you set up your flaming left hand, right, these 3 fingers are got to be locked. You lock it. You only turn your hand upside down. Your arm, you can turn like that, can turn, right? But your 3 fingers must lock, huh? Don't move, huh? Okay, come back to here. First finger follow magnet north to south, so you point up. Then these fingers are, okay, because follow the current here, here. Don't follow current here or here, here, inside the one in the magnetic field current. This current is from inside come out. That's why your hand is like that. Okay? This finger point up, magnetic north south. This one point up because the current from inside come out, no? Because current here flow out. So this one follow. Okay? And then you notice that when you put first finger up here, this finger put here, right? You notice that your thumb point to the left. That's why the force is go to the left. Okay, so this small wire being pushed to the left now because the direction of force is to the left. Okay, please jot down the hand, the diagram, and understand it. You must practice with your hand to understand it, how to find the answer. Okay, how to use your hand now, Fleming's left hand now. Follow here now, north, south, so this one point up, this one my neck. Current is coming out. Okay, so this finger must be like that. When this finger point up, this finger come out here, automatically you look at your own thumb, it must point to the left. Beside the force is to the left. Understand? Make sure you know this is Fleming's left hand rule. Okay? Can all right. Okay, come. Now we follow here. What is Fleming's left hand rule? Okay, please highlight. If the thumb, first fingers, right? Thumb, first finger, and second fingers of the left hand are held at right angle. If the first finger represents the direction of magnetic field, first finger here, that magnetic field, second finger represents the current, then the thumb will be representing the direction of motion, which is the force. Okay, the force. Can Okay, come, I give you one question. I want you to use your hand to find the answer. Come. Let's you see whether you wait, hold on. Okay. Can you look at your objective question now? Objective question, look at objective. Objective question, just look at your objective question, okay? We try some question first. This question. Question number 1. Okay? See how to get the answer. You look at this question. How do you put your hand? How to find the answer? Question number 1. First, you must follow the direction of current. If positive, you come up here, flow, follow this wire, cross over, then go back. Then magnet, given this one is north, this one is south. So for this question, you can follow like just now. First finger point up, north to south, right? And your second finger follow the current. The current is coming out. Coming out means this finger is coming out. Then this finger put out, this finger come out. You notice your thumb point to the left. So this piece of wire will be pushed to the left. So the answer is D. Understand? Answer is D. Using your Fleming's left hand to find answer 1, Okay? Right. Question number 2. I hope you can understand my fingers. Why the answer C? Okay, you study first. Why the finger is like that? You study. You notice, magnet north inside, south outside. So it's north indirect. This finger have to be like that. You have to put your hand like that already. This hand. A bit difficult for you lah. You have to turn your arm so that this first finger point to your face. Point to your face like that. Point to your face. And you know you point to your face, okay? Because from inside it come out, magnetic field. So point to your own face. And you must turn so that this second fingers are the current, this is current. The current go down. Okay, so must follow, this finger go down. So when your three fingers you do in such a way that this finger you face to your friend, your face, your own face, you notice that this finger point down, current. Then your thumb, you point to the direction of C. Can you or not? Can you do that? Use your hand. Maybe in my video here, you cannot see my hand, Maybe I see my video. Let me see, Sorry, you have to follow this diagram, sorry, So this one magnet, north to south. This one current go down. When this finger is like that, second finger like this, then your thumb point to the left side. So the answer C. Okay. All right. Question 3. Now you see. Use your hand like that to find the answer. Try to understand it. Why it's like that? Magnet north south. You see, magnet north south. Okay. So this finger follow the magnet north to south. Okay. Current. Current is from positive, come out, then it go down. Follow here now, this wire, then it go back. So current follow this direction, the current inside the magnetic field. So it's going down. So this finger down. Okay. Your hand, these three fingers lock it. When this finger follow this direction and current go down, you will notice your thumb point to the right side. The thumb point to the right hand side. Okay. Follow this diagram, so the answer is B. Okay. So far I can understand now. Wait, no, I don't know whether you can understand one or not. Anis, do you understand? Do you understand this Fleming's left hand rule, Anis?
Yes.
Can understand? Can use your hand.
Yeah.
Xiao Hui, Xiao Hui, Ong Xiao Hui, can follow or not?
Can.
Can Jong Han can follow. Jong Han.
Can.
Can Che can follow. Use your hand. Can use your Fleming left hand or not? Che.
Yes, okay.
Okay, Apple, what about you? Can follow?
Yes, teacher.
Can okay. Okay lah. Take a break, This still Kaiji, the picture keep on changing one, and now suddenly different pictures. Yi. Okay, what about you, TVH? Can follow or not?
Can.
Can follow, your good friend here or not, Chan?
Yeah.
Oh,
Yeah,
Chan
he's
Wen
there.
Kang. Yeah, I saw his hand already. Chan Wen Kang. Okay. Tan Chai Liang. Are you there now? Must call your name to make sure you're there, because some I don't know whether you're there one or not. Tan Chai Liang,
Yes.
do you understand?
Yes.
Where's your brother?
Copy không?
You sit together lah.
À,
Còn for swimming, okay?
Can teacher.
Can Chiu Tong can understand or not? Chiu Tong
Can understand.
can, okay. Let me see another name. All this Ngô, Ngô, are you there? Ngô à, you tại mà?
Yo.
Understand or not?
Understand.
Understand Huy Xin, do you understand? Yao Huy Xin?
Yes.
Yes, okay, good. Brandon, Brandon are you there?
Yeah, I'm here.
You understand or not?
Understood.
Understood good, okay. Chan Sing Kai, understand? Not there. Ku Kian Ming, okay, understand?
Yes.
Okay, Valerie, do you understand? Valerie C.
Yes.
And Mafuza, do you understand? Mafuza.
Yes.
And okay, Jocelyn Lee. Where are you? Jocelyn,
Yes.
do you understand?
Yes.
Selena, do you understand?
Yes, teacher.
Okay, good. Rian, do you understand?
Yes.
Yeah. Aisha, okay or not? Aisha?
Okay,
Aisha?
okay.
Okay, Okay, come let's move on now. Okay, come. Go back to page 1 Page 1 is very complicated already now. Okay, look at here. Carabao field. Here, can you highlight this term? Carabao field or resultant field. What is Carabao field? Okay, Carabao field means combine two magnetic field. You combine the two magnetic field. What is the result? That one is called Carabao field. Okay, so highlight. Carabao field are combinations field between combination. When you combine two magnetic field, two only, the most you can combine two only. Combination field between magnetic field produced by current and magnetic field by the permanent magnet, like just now here, right? Here, this permanent magnetic field. The other one is magnetic field inside the wire. The wire, when current flow, along the wire got magnetic field one, Okay, lesson 1 you learn So these two magnetic field, okay. So combination between magnetic field by current and magnetic field by permanent magnet. When you combine, so we call it Carabao field. Okay. Another combination is magnetic field produced by two current carrying conductor. Okay. It can be two wires. Two wires carry current. So both wire also got magnetic field. Okay. Yeah. Okay, now we look at the first one. First one, slowly take. I explain very slow. Don't worry. This one is Carabao field type 1, got type 1, type 2, type 3, Okay, type 1, here I don't explain. You look at this diagram. Okay, so here got two pieces of magnet. So here got one magnetic field already, right? North to south, north to south. So this magnetic field is here, north to south. This one understand, Okay, the first magnetic field from north to south is here. Okay, another magnetic field come from this wire, carry the current come down, right? So when current come down, you remember not use your right hand grip rule. Last lesson you learned. Your right hand clipping, you use your right hand to clip the wire. You notice that, The thumb point down, follow the current because current go down. So your hand is like that, holding the wire. So your right hand grip rule is like that, Then you notice that when you are holding like that, then you notice all your fingers are turned to follow this direction. Besides, this magnetic field become clockwise direction. Follow here, like turn here, turn like that. So clockwise direction. Okay. Yeah, use your right hand grip rule. If forgotten right hand grip rule, you go back, take lesson 1, go read again. Okay. So now there are two magnetic field. One is this permanent magnetic field. Another magnetic field, this and clockwise direction magnetic field is come from this wire. Actually, it's here, it's along here. Okay, routing the wire in this direction, magnetic field, right? Okay, right. Now, actually, when these two magnetic field interact, this one and this, the clash, you put them together. Interact, Interact means this magnetic field combine, put them together, so it become like that, isn't it? So this is north to south. The other one is clockwise direction. You notice, okay, I draw here lah. This one is a permanent magnet, north to south, north to south. This one is a clockwise direction magnetic field. You notice up here, the two magnetic field are same direction. You notice or not? Both go to the right. This one go to the right. Same direction. So when same direction, they will combine here, become strong. I put S only, strong magnetic field, because two same direction they will combine to become strong. Okay, whereas in the bottom, this one clockwise direction, this one go to the right, the opposite direction, so they cancel out each other, so they become weak W. So up here is strong magnetic field. Bottom here they cancel out, so become weak magnetic field. Okay, I repeat one more time for you. This magnetic field come from permanent magnet, you understand? This magnetic field clockwise come from this wire carry current. So when you combine these two, you put them together, right? You notice up here, this magnetic field and this same direction. So same direction, the combine becomes strong. Bottom here, opposite direction, you see now? This one go to the left, but permanent magnet go to the right, so the cancel. Once it cancel already, this part become weak magnetic field. Okay, now when you have strong, when you have weak, right? Different, you have a net force already. Up here is strong, bottom here is weak, so got different already. Different, so can produce a force. So the force push down, because strong push to the weak. So the force will push down, okay, like that. So this is the direction of force. Okay, force. Okay, force is always acting from the strong region to the weak region. Up here strong, bottom is weak, so it push down. Understand? That is the force. Okay, now to draw this diagram, you must see carefully. You cannot draw this diagram as your answer. Cut-about field is not this one. This one is a rojak, like that you cannot see one. So what you need to draw is only like this. Julian come in. Just I saw his name inside already. He left and now come back. Okay, you draw like this. When it's strong region, right? Strong up here. So you draw more lines. You see the line? North, south, more line. Okay, very close. When you draw the lines closer, means here the magnetic field is stronger. Strong, you draw closer. Okay, you just follow like this, north to south, but here become closer. That's it lah. Then you draw the line closer. Okay, whereas at the bottom here is weak, right? The line very far. So you draw one here, enough already lah. Then just use an arrow to show the direction of the force. The force is going down. Okay, up here is strong, bottom is weak, so the force pushes down. So force is here, so this is the result. Okay, usually in the SPM, they will ask you to draw this diagram. Give you this one you imagine yourself, they want you to draw this diagram as an answer. Draw the cut-about force, the cut-about field, right? And also the force. Okay? So understand this diagram? Okay, Then Okay, now we move into the next one. Next one is here. Okay, this one is another one. This one is type 2. This one more complicated, you take your time. Huh? Okay, now look at the battery. So the current here go up. When current come up on the paper, so it's a dot. Use your right hand grip rule. Your hand, the current go up, so it's like that. Right hand grip rule. So you notice your other fingers are all turning in anti-clockwise. Anti-clockwise, so it's here, you see, anti-clockwise. Okay, then the current come down, go in, come back. Okay, this part the current go in, so you put X. So when current go inside the paper, so your right hand is like that. Okay, then you notice your other fingers all follow the clock. So it's clockwise direction. So here clockwise direction. Okay, so you see now on the left, right, so it's here no. Here anti-clockwise, so it's here. Here clockwise direction, so you put it here. What about this one? This one is another magnetic field come from the magnet lah. You see north, south, not permanent magnet or magnetic field north to south, north to south, north to south. So it's here, right? So actually here three, this one permanent magnetic field, north to south. These two actually come from the same source come from the current. So we assume this is only one. So still two magnetic field. One come from permanent magnet. These two from current. So when these two magnetic fields interact, when they clash, so what you do is you put this one inside here now, become like that. Okay, this one put here, this one put here. So now you can see carefully now. You must see carefully know why here is weak, why here is strong, why here is strong, why here is weak. I don't want to tell you. Can you tell me why? Why here is weak, strong, strong, weak? Why? Why here is strong?
Opposite direction.
Yeah, here same direction, correct not?
Yes.
Same direction, so here becomes strong. Up here, opposite direction, so weak. Then here, same direction or not? Same direction, right? No, you can see here, here north to south, this is same direction, so same direction, the combine so become strong. Over here, this one go to the left, but this one go to the right, cancel. So weak. Understand? Understand why it's strong here, weak here, strong here, weak here, right? Aisha, can or not? Aisha?
Can.
Can, you know why this one strong, this one weak, this one strong, this one. Okay, now you draw the catapult field like this. Strong, I told you, right? Strong, you draw the line very, very close. So here, close. Okay, up here also close because here is strong, here is strong. You only draw the line for strong region, strong. Okay, here is strong, so you draw a lot of line here. And also here is strong, so you draw many, many lines here. Okay, the other parts you can ignore, you don't need to draw. We only draw the magnetic field lines at the strong region. Here is strong, right? Here is strong, so just draw like that, okay? And then the force here go up. Why go up? Because bottom strong, up here weak, so it pushes up. A lot, my personal word, this thing always keep on come out. Okay. Yeah. So this arrow go up. You see, strong push up to the weak. On the right side, strong push down. Okay, so the arrow go down. Okay, you see, this force going up, this force going down. Understand? Now, another thing can happen, What happens when there is one pair of force in opposite direction? You see that? This one go up, this one go down. What will happen? Not balance, right? So when one force go up, the other one go down, so you will start to turn, One is going up, the other one going down, so you start to turn. So this produce a turning effect. turning effect means I can make our fan turn. It's because of the force, you know. The force are acting in opposite direction, one up, one down in opposite direction. So we cause turning effect. So slowly you will learn now. Turning effect. That's why the car tire can turn, the electric car, right? And also a house fan can turn. It's all because of the turning effect. Now very famous already, we have electric car. All the electric car using this concept, use a magnetic force to make the tire, the wheel to turn, then to run the car. Understand? Yeah. That is the reason you need to study physics and all. You see, there's so many technology nowadays. The latest one, the most popular now is electric car. Electric car, okay, I can tell you in Malaysia, in 5 years, 10 years time, you can see on the road here, all the cars are soundless, no sound one. All electric car no sound one, you know. Then later on, you very scary, you know, after 10 years, now you're only 16 or 17 years old only, right? Another 10 more years, when you are before 30 years, you notice that on the road, all the car moving around, but no sound one. No choice already. We have to move into electric car because our world is petroleum going to finish already, you know. Only can last 10 years, 10 years only. It can going to finish. So we have to shift to use electric car. So all the electric car, later on you see on the road now, all electric car all moving around, no sound one, very dangerous, you know. Very easy to happen accident because no sound. The car come to you, so you don't know. Okay. So this one okay, All right, next one. Next one is here. Look at this diagram. Okay. This diagram, I think easy to understand now. Now no permanent magnet. 2 wires only. This current come out from positive, here come out. Come out, use your right hand grip rule, point up, right? Your other fingers, anti-clockwise. This side here, anti-clockwise. Then on this side, same. The current also go out, also come out. So your hand also same. So also anti-clockwise. Both are same now. Same anti-clockwise. Here anti-clockwise. Now is the same here and here. So what happened then? These two magnetic field they will interact one, you know. Okay, in between why become weak leg? Why I put here weak? The end, why I put here weak? Why here become weak?
Because opposite direction.
Yes, you see the magnetic field opposite direction cancel out, so become weak. Center is weak means comparatively the left side becomes strong. Right side here also becomes strong. So this one is common sense. If center is weak, right, on this side becomes strong. This side becomes strong. Understand? So what happens is, if the force will push this one in, push this one in, so the two forces will push in like that. Okay, excuse me. I think my rooms are aircon are too cold. I will increase the temperature a little bit. Okay. Yeah. Right. Now, just like I said, here is weak, so here is strong now. So the force must push the wire. The wire is here, so the force push in. That's why you see the force here push in. Okay. Over here, same. Here is strong, so center is weak, right? So it push to the right. So pushing from the wire, push here. That's why force is here. Okay. So draw. So this diagram is like that, you know. As I told you just now, we only draw the regions of strong. Weak here, center weak. So here center only draw already. Only draw the left side here strong. You draw the wire very close. The magnetic field, this follow this direction, right? So it's still turning like that one, you know. So here you make it very close. Same thing here. But this arrow wrong already, sorry. It's supposed to go up. Okay, here. This arrow wrong already, the arrow should be like that. Okay. Not this one, this one wrong. Huh? Follow here now, it go up. Okay. So this arrow go up. Huh? So you draw the line closer. Here closer. Okay. This one like that. This one go up. Okay. So here you put X. X means that is neutral point. Neutral means that the magnetic field all cancel out. No magnetic field become weak now. So it's neutral point. Center is neutral point. Right? So we make a conclusion, when two wire move to the same current, move to the same direction, the two wire will be attract each other. Why I say attract? Because the force, this one pushing, it will make the two wire attract each other. Attract. Remember now, when current flow in same direction, the two wire will attract each other. Attract. So this attract. Okay. Okay. Next is opposite direction. This current go up, this current come down. Okay, you see what happened? This one go up, use a right hand grip rule, anti-clockwise. This one come down, right hand grip rule like that go down. So it's clockwise direction. So this one anti-clockwise, so you put it here. This one clockwise direction, you put it here. Center now becomes strong. Why strong? Because you see same direction. Same direction, so become strong. When center is strong, automatically left side is weak, right side also weak. So you can draw now. Okay. Our drawing, I told you just now, right? We only focus to the strong region. Strong, So here you draw the line very, very close. Follow this direction. Okay. So you go up, you turn like that, right? But make here the line very close. Center is a straight line. Straight line, okay? The arrow go up. Okay, here the arrow also go up, So you draw like that. Okay. So only this part only you focus. The other part weak one, actually you don't need to show. Now the force is this one, center is strong, push to the left. Strong here, weak here, push to the left. Here strong, here weak, push to the right. So push to the left, push to the right. So what happens is the two wire will repel each other. Okay. So remember now, wait. This one always came out in the SPM one, When two wire carry current in opposite direction, one up, one down, the two wire will rebel. Because the force is going up, going out. Okay? Like this one, when two current carry current in the same direction, they attract each other, they attract the wire. So these two wires become closer, attract. So when opposite direction, they rebel. Okay, push out. Okay? Understand? So far okay or not? Pong Yong Eng, do you understand? Pong?
Yes, sir.
Then, okay, good. Kirtana, do you understand? Kirtana,
Yes, sir.
understand or not?
Yes.
Then, okay, good. Chan Yen Wu, can hear or not? Chan Yen Wu? Then, he used to type only, he used to type one, I know, I understand why. Yes, he said yes, okay, can understand, thank you. Yvonne can understand?
Yes.
Can, thank you. Apple can understand?
Yes, teacher.
Can, Hanis, okay, Hanis understand?
Yes, sir.
Good. In ân nào? Can I understand? In ân. In ân no sound. No sound means disappeared original, not there. Belton understand?
Yeah,
Belton.
yes, sir.
Can I understand?
Can.
In ân type there. Yes. Okay. Thank you. In ân. Belton. Okay. Jonghan, are you there?
Yes.
Do you understand?
Understood.
Okay, good. Okay, Julian E,
Understand?
can you understand? Okay, good. Julian. Who can Ming, okay or not? Who
Yes.
can Ming?
Yes. Yes.
Okay, good. Right. Mafuza, understand? Mafuza, are you there?
Yes, sir.
Okay, thank you. Your voice are very nice, Mafuza. Wen Xian, are you there? Wen Xian? No, cannot hear. Or put good sign. Put like that. Good. Okay, thank you. Nicholas. This Nicholas. Nicholas, can you hear me? Nicholas,
Yes.
you understand what happening now or not?
Okay, yes, sir.
What happening tonight? Do you understand?
Mm.
You understand?
Yes, sir.
And Valerie C.
Yeah, I can understand.
Okay, thank you, Valerie. Yunsi, can understand?
Yes.
And Liao Xingxiang, okay?
Okay.
Yeah. Jock, okay or not?
Okay.
Okay, thank you. Okay, Selena, okay.
Okay.
Yeah. You know why I call your name or not? Because I want to make sure that you're there. You are there, paying attention, Some you on your handphone, on your computer, you got childhood. Because you know why, this parent call me, after this on my class, parent, I do want to tell who lah. It's your parents, okay? Your parent call me to complain to me, saying that the son not paying attention. Your mother told me that the son on the computer, and then he saw Mr. Tan teaching, but my son playing the handphone. The mother called me, to complain. Then I told the mother, I cannot see your son, so you must go and check your son. Check your son. Make sure your son focus. Pay attention. There are 3 parents call me, to complain, That means you know why I call your name now? I want to make sure you're around. Okay? Your parents, you must be careful, Your parents I told you all your parents already. The parent will check on you on the computer whether you pay attention one or not. Some on the computer, you can press the play handphone, then let Mr. Tam talk, never listen. Cannot, you must be confined already. Understand? This is a time you have to adapt to this kind of learning method already. Okay, we call it what we call it new normal. Our Prime Minister also say Tan Sri Muhyiddin say what new normal. So it's a new way of life, new way of learning. Everyone has to adapt already. So you cannot expect your teacher every time you must study. Your teacher must be in front. Now cannot already. At least I tell you, at least 1 more month, you have to go on like this, Go on, use your computer, use your handphone to look at me every night, go and learn. Have to adapt okay? I tell you, adapt one time cannot understand your mind, you go and see the video to understand it, okay? New normal, this is called new normal learning method, learning environment. Okay, I tell you when the school reopen from 5 students go back to school, right? You also cannot expect your teacher sit in front of you to teach you already, because one classroom only can put 15 students. So some of you are one class have to separate to 2 or 3 groups, So how the teacher going to teach? So most probably like for the case in my school so we will divide, certain teacher teaching Form 1 to Form 4 one, they don't teach Form 5 one, they got no job, So we will divide the timetable. Ask a Form 1, Form 2, Form 3 teachers are going to teach you also, I can only teach one class, for example, in my school. 5 size 1, for example, 5 size 2 or 5 size 1. So 3 group of students, I can teach one group. Another 2 groups I have to ask another 2 teachers which is not teaching physics to teach. Go inside
Really?
to jaga you only.
Really, sir?
Yeah, what to do? I'm planning the timetable already like that.
Send me.
So how? CDS also same one, IJC and GS also unless your school you have a big hall, so 40 students can put 2 meters from each other, put inside the big hall. Everyone sit in the big hall, then one teacher can teach. Okay, big hall. So 40 students can sit inside, but must sit very far away from each other So at one time, one class 40 students can go inside a big hall. So the table, one table, you sit like that. So you have to study like that. Okay, right? Okay, so no choice for class. Very young say GG. Okay, never mind, we move on. Okay. You're still lucky you can go back school and all. Then the Form 1 to Form 4 one, don't know when they can go back to school, don't know yet. Maybe next year only. Maybe next year they go back. Like Form 3 one, only sit for PD3 already. The straight away jump to Form 4. Okay. Yeah. Okay, this one done already. Okay, I think last part before I stop. Look at it. Factor affect the magnitude of force on the current carrying conductor. What is the meaning of this? So it's like this. I take this diagram now. Okay, just now we already studied, right? When current flow like this, crossover, go back, there will be a force, right? This force will push this wire to the left side by using Fleming's left hand. Correct not? Okay, but now how to make this force stronger? How to make the force here stronger? Okay, please highlight. The first one is the strength of magnetic field. Use stronger magnet. This magnet use stronger magnet. Then this force becomes stronger. Okay, the strength of magnetic field. Highlight now. When the strength of magnetic field is increased, you use a stronger magnet now, right? So the force acting on the conductor increases. So this force becomes stronger. So this wire, short wire, can be pushed further because the force stronger, right? You highlight. To increase the strength of the magnetic field, you can using more powerful magnet. Use more powerful magnet, or by placing the magnet closer to each other. Okay, you can put this magnet and this magnet closer. Also can make the magnet stronger. Understand or not? So remember now, first method is use a stronger magnet, the strength of the magnetic field. Either use a stronger magnet, you cannot change the magnet, so you put the magnet closer. Understand? Okay, the second one, the magnitude of current. The current, you make the current stronger. Okay, magnitude of current. You make the current stronger, so the force becomes stronger. Okay, when the magnitude of current is increased, the force acting on the conductor also increase. Okay, when you increase the current, the force becomes stronger. Okay, right? To increase the magnitude of current, right? You want to increase the magnitude of current, you can use thicker wire, same length. Why do using thicker wire can? Liao Xing Xiang, why use thicker wire can? Why use thicker wire, Liao Xing Xiang?
Less resistant.
Yes, correct. Thicker wire resistance low, so the current will become more, correct not? Use thicker wire, or use a shorter wire. Shorter wire, so can same reason now. When the wire shorter, the resistance lower. Correct not? Shorter wire. Or another one is you increase the power supply, increase the electromotive force of the power supply. Okay? So remember now, these two are sure come out one, I tell you. How to increase the magnitude of this force. So two, remember, one is the strength of the magnetic field. The other one is the magnitude of current. These two. Please make sure you know all this. Okay? So far can, Nicholas, okay, Nicholas,
Okay.
okay, Nicholas become very, very quiet already, Nicholas, your good friend Eric there or not? Eric?
Don't know.
Yes, I'm here.
Eric is here. These are
Yeah.
Leonard, I never see him, Leonard. Leonard disappeared already, Okay, now mind. So let's go through a few questions, Okay, come. Few more questions, Just now we solved number 3, number 4. Okay, now look at question number 4. Why the answer A? Who understand it? Why the answer is A? Why then? Why the answer is A? See how I arrange my Fleming's left hand like that. Magnetic field is north south. You see, north to south. So this finger always follow one or follow the magnetic field. Okay, I tell you what. First, you set your hand like that. Okay, 3 finger you set it. You must lock your fingers. You remember. Mr. Tam say one, every time use your hand, make sure the 3 fingers are locked. Ini kunci, jangan bergerak lagi, ini 3 jari. Lock the 3 fingers. Understand? Lock it. So what you can do, you only turn your arm only. By that only, You cannot turn your fingers one, cannot. The finger is already locked like that. You can only turn your arm only like that. You turn upside down, turn your arm only, understand? Then come back to this question. Magnetic field, every time you follow the magnetic field, okay, you turn your first finger, follow magnet, north-south. Then how you turn your hand, you have to practice lah. Don't turn your finger, turn your hand. Turn your hand so that this finger point to north to south, point here. Then current, X means the current is going inside. The current go in the paper. Current go in. Current go in means this hand must point inside the paper. Because current go inside the paper. So this finger must point to the paper, go inside paper. This one go to left, this one go inside the paper. Current go inside paper. Right? You practice, use your hand. First finger follow here, north, south. Your second finger, this one, point inside the paper on your paper. Because the current is going inside your paper. This one point to your paper. And then you notice your thumb actually point up. Point up. Okay? The point up means the force is going up. So direction is A. Okay? Very technical. You must practice a lot. Okay, number 5. Another question I see. And you need to use your hand a lot. You see, this chapter very technical. Why the answer A? You see my hand? Can you understand? Remember, the 3 finger cannot move. Fully move your hand. First time, sure, you go and catch a magnet, north south. Your first finger follow this one, north south. Current come out. Current is from go inside, come out here. So it's come out. So your second finger current come out, and then this one come out. This one magnet, first finger go in. This current come out. Current you don't follow here. Here no. You must take the current inside the magnetic field one. So this direction, so this finger come out. Then last only you look at your thumb. Now you see your thumb point up. So mean the force is going to direction A, go up. Okay. Can Kirtana, okay, yeah. Can you understand? Kirtana.
Can understand, sir.
You can use your hand or not?
Got.
Your hand moving around or not?
Yes.
Good. Okay. Must use your hand, because in the exam later on also you must use your hand, man. So don't be shy. Use your hand. Understand? Okay. Last question. This one you're going to understand. This one I don't show the diagram already. No diagram. Okay. Why the answer is C? You can understand it. Why the answer C? Take your time to understand it. Must follow the current. Okay, current here positive. So come out here, follow here. We go up, come over here, go in. This is mercury. Mercury can conduct current one, so the current come out. Okay. Okay, mercury can conduct current now, so the current come out, then go back. Okay. So magnet, this is north, this is south. So your hand, fingers, first finger follow here, north to south. Second finger follow current from inside come out. Okay. I think it's the same like this one, same diagram. Magnet north south, right? This one. This current come out. Okay. Then a thumb point up, then why is Z? Let me see. X to Z. North to south. Current is coming out. Come out. Okay. Okay, like this lah. For this question, you take current go down lah, go down. Okay, the current go down. Magnet like this, current go down. And then the force is coming out. You see your hand, not this diagram. Magnet north south, current go down. Your thumb point outside here, this direction. Okay, your thumb point out. So the answer is X to Z. Okay, from X to Z lah. So the answer X to Z. Okay. And okay. I'm going to stop here lah. 10 o'clock already. I want to stop. I don't want to drag so long. Very boring. I know. You look at the computer, look at your handphone too long. Not good. Okay. For tonight, I stop here. I know you need to revise again. You can read through again, see the video again, go and understand the lesson. Quite technical today lah. Technical, you have to repeat many times to understand it. How to use your hand, especially how to use your Fleming's left hand to answer the few questions. Please go through it again, okay? Understand? Any question to ask or not? Anyone here want to ask any question? Chiu Tong, any question to ask? Chiu Tong?
Tak ada.
Any
Male.
question? Any question?
No.
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 Yes, okay. For swimming, any question?
No, teacher.
No question. Yvonne, any question or not?
No.
Hi, Yvonne. Leo, any question?
No.
No. Tan Chie Yin, any question?
No.
No. Okay, if no question, so I stop here tonight. Thank you very much for coming to join me. Okay, I want to see you on Thursday again, or Thursday every night, 1.5 hours. Because I want to see you 1 week 2 times so that you don't forget physics. If not, you will forget physics, you don't study physics. So I want to see you more often so that you don't forget physics, don't forget Mr. Tam. Okay? Okay, thank you. Bye-bye.
Thank you,
Thank you,
teacher.
sir.
Thank you,
Thank
sir.
you,
Yes, sir.
Thank you,
Bye-bye.
sir.
Thank you, sir.
Bye.
Thank you, sir.
Okay, bye-bye. Bye. Okay, bye-bye.